Thank you all for coming. This is a series of events that we have here on technology and stuff. You should, if you're not already, sign up for our email list and follow us on Twitter, code as craft. There's snacks and beers over that way. The bathrooms are first right, first left, over that way. Now that all that's taken care of, Laurie, Denness, Marcus Barczak, pillars of the world-renowned Etsy operations team. This is a talk they gave at Velocity in Europe on how we integrated multiple CDN providers, and you'll hear the rest from them. So thank you very much for coming, and thank you.
The pillows of Etsy operations. Thanks, Seth. Thanks for coming, everyone. Today we're going to talk about a project that we have undertaken over the last 12 months. We started sort of early 2012, looking to integrate multiple CDN providers into Etsy's content delivery network here. So, a little bit about us. This is Laurie.
And he's Marcus.
So Etsy is a platform that enables people from anywhere to buy and build, or build and buy from creative independent businesses. We have over 30 million members on the site and over 18 million items listed as well. We have 60 million monthly members and 1.5 billion page views every month, so traffic's pretty nuts. We've seen exponential growth over the last sort of 4 or 5 years.
On the tech side of things, we have a strong engineering culture. We practice small, frequent changes, lots of deploys. Normally around 60 times a day, we're pushing changes to the site, trying to stay strong and fast.
Rockin'. So a little bit of background. We first started using a CDN back in 2008. We've seen exponential growth on the site since then. And as I said in the intro, at the start of 2012, we began investigating what it might look like for us to run multiple CDNs for Etsy.
So why would you use a CDN? Who currently is using a CDN? Awesome. So this is pretty obvious then. Basically, it's going to make things fast. We're trying to improve last mile performance by having the content close to the user, and to offload also the content delivery to them. Reduce loading origin infrastructure to make bandwidth and cost savings. So just try and get a consistently fast user experience for all of your users.
So then you have to ask, why would you want to use more than one CDN? Is anyone here actually using more than one CDN? All right. There's one person up the back. He looks familiar.
Yeah.
So yeah, there were sort of 3 main aspects that we were wanting to explore with running multiple CDNs. The first one was resilience. So like we've just had Cyber Monday, which is the biggest day of the year for us, and we were doing like insane amounts of traffic. So back in before we were running multiple CDNs, having that single CDN, if we had issues of that during the middle of the day, it would have been really horrible for our sellers and for our buyers as well to be able to access the site. So one of our theories was if we could run multiple CDNs, if one fails, we can turn them off and flip over to another one. Second aspect was flexibility, so having that ability to be able to turn a CDN off should there be problems or you're seeing performance degradations. And then the last one, of course, you couldn't do all of this without talking about cost. We won't talk too much about that, but having multiple CDNs gives you a few extra levers to pull to tweak how you're managing your costs, both on the back end for your origin delivery, bandwidth, and also for your front end.
So the plan, very quickly, we have a few steps here. We're going to go through in detail, establishing the evaluation criteria, do some initial configuration and testing, testing with some production traffic, and then operationalizing. So we'll go into that some more detail.
Cool. So first up, evaluation criteria. So we chose to explore some different CDN providers, and we wanted to decide like how we're going to actually evaluate them. So we chose 4 key criteria that we're going to look at for evaluating them. The first one was performance. So having run a CDN for a number of years, we had a pretty good understanding of like our baseline, the baseline performance boost that we get from actually running a CDN. Our response times, when we're looking at other CDN providers, when we start delivering content through those guys, we don't want to be seeing like any more than a plus or 5% increase or degradation to our response times. And also hit ratios and origin offload. One of the benefits of running a CDN, being a cache, is that on the edge you're offloading most of that content delivery to the edge and to that provider's network. So from our baseline, we were getting around about 80 to 90% hit ratios. We would expect that another provider, when they come in, would be able to achieve similar performance. For our images, for instance, we have a really long tail of content, so the working set's really huge, so it's quite a good test for a CDN provider to determine can they actually handle the workload we're going to throw at them. The second criteria we're looking at was complexity with the configuration. So if anyone's using an existing CDN provider, you probably have a love-hate relationship with some aspect of them. So complexity is a really big thing when it comes to the configuration. Do you have to push them up XML files? Do you have to use a web interface to make changes? Do they have APIs available? Like, how well does it work with the way that you work? Self-service, can you make those changes yourself? Or is it a call to professional services and then a big epic mission through there to actually like try and get someone to do that change for you? So can you actually make those changes yourself? And the last one is the latency for the changes. Like, how long do you actually have to wait when you want to make a change? Is it seconds? Is it minutes? Is it hours? Is it days? So latency is a really important aspect for us. For when we're running multiple CDN providers and need to make a change, can we do them all relatively quickly?
So moving on to the next set of things, reporting metrics and logging is very important to us. We want to know what's going on with the CDN. So, for example, resolution. Are able to provide you status code breakdowns, maybe per data center, how many errors, requests a second, and what the frequency, like, is it once per minute, is it every hour, or is it longer than that? How soon can you get those metrics? Is it real time? Is it delayed by some period of time? It's no good having those really high performance metrics if you can only get them a day later. Delivery is important too. Bonus points if they have syslog straight to origin, and also APIs to deliver the metrics. And then customization as well, like control over the logging detail, if any, coming back to origin. So I mentioned we pride ourselves in our culture here, and we like the CDNs to at least understand and participate in that. For example, big proponent of blameless postmortems. So when an outage happens, we want to know what happened and why, rather than just hearing some guy got fired for it. And a great example of this is we actually did have a CDN come in and talk to us here at the office, and at the end of it, we had remediation items for both parties. We learned exactly what happened, and we both went away having learned things and how to fix things in the future. Obviously, we'd love access to technical staff, accessing, sharing PCAP dumps directly over IRC, fantastic, versus, maybe going through a support system. And at the end of the day, this person's serving the site for us, so it's a shared success, and we want them to be as vested in the site as we are, because we kind of like it. We want it to be online and be available.
Cool. So now that we've established these evaluation criteria, and we chose a few candidate providers that we're going to put under the test, it will start to actually get into how do we do the initial configuration, how do we start doing our testing of these.
So as you mentioned, we had one CDN to begin with back in 2008, so lots of craft had built up. We had a lot of business logic in the CDN side. Needs have changed over the years. It's time to go and audit all that and pull as much as possible out of the edge. A great example of this, caching TTLs, there are RFCs for this. Sure, you can go and set MIME types in the CDNs and set how long you want things cached for on the edge, but actually there's very easy, well-defined ways to set cache control headers that the CDN should honor. So it's a very simple way to do that and avoid complex configuration. And similarly as well, gzip compression. This one has two benefits. Again, you can do it at origin, and it also means that content is then compressed for origin to the CDN, saving you more traffic and money. So basically, these are two good examples, but if you can do it at origin, do it at origin. Don't try and put complex logic in the CDNs, because if you maybe have 10 of them at some point, you're going to have to make all those changes in all of them. Obviously, some situations it's not possible to do everything from the CDN side, but if it's possible, do it.
Cool. So as we were getting into this, we started using this phrase, the mean time to curl. So when we'd go to spin up a new provider and start playing with them, what was the mean time for actually doing the initial configuration and then actually pulling an object through them? So like the absolute most bare bones basic test we could do. So the way that testing would kind of look is, for instance, here we've configured up our new CDN. We're going to fetch some image. basically just using curl, pulling the headers back just to check that things are working. So make this simple request at the command line. Bam, we're seeing HTTP OK, so the object was actually served successfully. It's come from somewhere, and it looks like our image. And we can see in the headers there that it was a cache miss, and there's been no cache hits, so it's a new cache. We would expect that. When we run that request again, we then see, yep, it's still okay, that's a good thing. We're now seeing that it's a cache hit, and the cache hit counter is incremented by 1. So if we can continue doing that, we've sort of been able to, in a really, really fast way, just determine, like, we've set this up and it appears to be working. So that's, for us, like, was the very first test that we would do when we're setting up a new provider. So then a couple of the most important things about mean time to curl was that there shouldn't be any need to touch your existing infrastructure. So when you're setting up a provider, if you have to go and start modifying your web server configurations to support them, that's usually a warning sign that they might not really be as flexible as you need them to be. It's a great smoke test of functionality. It's the simplest thing that works in terms of fetching an object and checking that caching's working. Our record was 10 minutes, so 10 minutes from literally signing up and setting up the initial account to actually pulling an object successfully. And with host header hacks, you can actually see it working against the site as well. And any new providers that we spin up, we would expect to be able to, like, run this test, and it's as good as plug and play, basically.
So with the initial smoke test done, it's time to break production, or hopefully not break production. So we tested with images first here. The reason being it's a really good test of caching performance. We cache our images, we have a long tail, as Marcus mentioned, so it's a really good way to get an idea of how the CDN is going to perform with your content. And also it's so easy to do because you're basically just swapping out a host name. You have an image tag on your site and you just put a new CNAME in there instead of using your existing origin one. And this was made really easy for us by our A/B testing framework.
Cool. So there's actually been a couple of, if you dig around live stream, I think there's a talk that Zidar did about the A/B testing framework that we have. So built very deeply into Etsy's code base is a thing that we affectionately call the A/B testing framework that allows us to test, basically execute A/B tests against real users. Where a certain code path will be executed for user A and a certain code path will be executed for user B. So the way that we utilized that for doing this image testing was that for users in the B variant of the test, they would get an alternate CDN, and we would just swap out the href, the host name for the images. So if you're in the A bucket, it's business as usual. If you happen to be in the B bucket, you'll get an alternate host name that we've configured that points to the new CDN. Some of the cool features of the A/B test framework is that we have really fine-grained control. So we're able to enable a test for just individual users. So say, I'm just going to enable it for my own account. We can enable it for a group of users. So all of the Etsy staff may have the B variant switched on for the entire duration of their browsing on the site. Or we can ramp up percentages of users. So we can say, we're going to let 10% of users see the test, or we're going to let 50% of the users see the test. This is all managed through code. So we set up some configuration in the code that just allows us to choose between how the test is configured. And the benefit of that is it gives us, like, complete and rapid rollback. So should something go horribly wrong, we just do a quick production code push and it will turn that test off without any sort of nasty side effects. So this is an example of, like, how we configure up the mappings. So these are, like, 3 CDN providers under test. We're using alternate host names for each of those. So if you happen to be in the B test and we're testing Edgecast, for instance, then you'll get image 0, image 1 -EC for your images rather than image 0. And then the actual test controls look a little bit like this, where we've got the test enabled and we can assign weights for those named parameters. So at the moment this is set to 100% origin. If we set it to say 50% Akamai, then 50% of requests would be served from Akamai and the other 50% would be served directly from origin. And then the last really cool feature is we're able to specify a URL parameter to override, to essentially switch that test on for any request you want. So if you actually want to test a specific page before you have the test enabled for everybody, you can just pass a parameter in and bam, you'll see what the test looks like, which is great for testing.
So before we go to production, we set up some monitoring. Monitoring is a P1 service here. We can't be flying blind. We want to know exactly what's going on before any of that traffic hits the users.
So yeah, so there was a tweet back in 2008 from a guy who looks sort of like this guy, which was, if it moves, graph it. which is something we kind of like live or die by at Etsy, but we've kind of extended that a little bit now, and even if it doesn't move, graph it anyway. So we graph the proverbial shit out of everything now.
So the simplest approach here is some provider dashboards, like maybe the CDN providers you're using have dashboards available to you. Fantastic. Some of them are good, some of them are bad. This one is a particularly good one. We've got per second updating, full of metrics with very fine detail and even some cool visualizations of where traffic's coming from. But this isn't available everywhere, and we wanted to have more detail by pulling this in-house as well. So it's actually very easy to write scripts to pull data from those APIs. Hopefully they have the APIs. Back in our evaluation criteria, that's something we want to see. So we can then make dashboards in-house with this data. So basically, quick PHP scripts, my terrible PHP, turns into some graphite keys, and then we later make that into some dashboards, and we'll go over these more later.
Cool. So now we've got some monitoring in place. We've got our providers set up and ready to go. We can do our A/B testing. This was sort of a really rough overview of like what our testing plan was going to look like. So we tested each CDN provider in isolation. So we didn't ever test multiple providers together. So we'd be testing our existing provider against a new provider throughout the process. So for each one of those providers that we were testing, we just start ramping the traffic up really slowly and steadily. So when we've set up these new configurations, we're going in with a completely cold cache. So if we were to actually ramp that up to 100% straight away, every initial request is going to be a miss, and our origin's going to end up in a molten pile of rubble. So with the A/B testing framework, we were able to very progressively ramp up the testing as we went. I think in all, it took around about 2 weeks to get us up to around about the 80-90% cache hit ratio for each provider. So we sort of started off with 1%, got some confidence, and then kept going. So throughout that process, we were just watching the traffic increase, looking at the provider dashboards, using the data that we were getting back from them through the APIs to verify like how many requests per second they're serving. We'd then, as the caches warmed up, we'd see the origin offload start to increase, and then throughout the whole process, we're really watching like what does end performance to the users look like. We don't want to be degrading that end user performance, and we'll talk a bit more about that later on.
So there are some downsides of using this approach. For example, the A/B testing framework is awesome, but we can't use it to test the main site. The reason for that is obviously, excuse me, the decision for that is made on the client side versus the server side. So this is great for images, but it can't go any further than that. Another thing as well, which is kind of annoying, is exposing test names. Obviously, because you are just switching out those image tags, our users love to share the images around via email or whatever, and now you're having to maintain this infrastructure who've hot linked these images, and you can't get rid of them, otherwise this happens, and those images are dead.
So now we've got all that going. How do we actually know that it's working correctly, or more importantly, how do we know when it's broken? So we've got tons of graphs. We look at the graphs. Are we seeing like unusual profiles on any of the traffic graphs? Are we seeing a larger rate of 500s than we would expect to be seeing? Another really awesome feature that we have is our community is not shy in telling us when things are broken. And we have a tool called the Forums Watcher, which basically watches our support forums. We have like a help forum and a bugs forum. And it keeps essentially a leaderboard of like the hottest topics at the moment. So for instance, when images break, up pops a really hot item of, like images aren't working for me on the site. So it's a really good early warning system for when things might not be going right. And then our support team's awesome as well. And they're the first ones that will tell us when, they're seeing a higher than normal incidence of people sending messages in saying, look, things aren't working correctly. And we really make sure that like when we're doing all of this testing that we keep support in the loop from like the absolute get-go. So we let them know what we're planning on doing. We let them know when we start testing. And as we start incrementing those percentages, we just keep them in the loop so they know that we're kind of screwing around with stuff, and to be a little bit more on the alert for anything that seems a bit unusual. And false positives are a good thing. Like if they start sending us reports saying, look, is this related to the change, and it's not, like that's still great because then we don't miss anything.
So we've tested the images now on all 3 CDNs. We've gained confidence in those providers. So now we move on to how we operationalize them.
So for a little bit of background on Etsy's sort of site architecture is this is like an example of the homepage. And we actually break our content out into 3 separate domains. So we have the www.etsy domain. That serves all of our dynamic HTML content. It's where the code is executing and serving the dynamic pages. We also have a domain called site.etsystatic.com, so we've broken those domains out to get the benefits of a cookie-free domain, and that serves all of the CSS and JavaScript and static assets on the site. And then the last one, which we've kind of touched on a little bit, is there's the images domain. So it's image 0, image 1 are our 2 sharded image domains, and they serve all of the product images and avatars and everything else. Which essentially gives us these 3 separate domains. Each one of those is behind its own separate set of infrastructure, so we effectively have 3 separate origins, which in turn means that for each CDN we actually have to have 3 separate configurations to manage those. And in doing that, like one of the things that we really wanted to be able to do was to be able to balance each one of those independently. So for each of those domains we can control how they're routed to the different CDNs as well. And Laurie will talk a bit more about here how we're balancing in production.
So as we discussed, we can't use A/B testing. How are we going to do this going forward in production? We chose to use DNS for this. We're already a Dyn customer, and they have a product called Traffic Manager, which is really great because it basically turns a very simple DNS lookup into a dynamic system that lets us to return records based on a set of rules. For us, this is weighted round robin. We keep all 3 CDNs running at the same time. And so when you make a request in the old days, it looks something like this. You make a simple DNS request and you get back a CNAME, an A record, and it goes to your origin or your existing CDN. And so what happens now is, based on those rules, you're now going to get one of 3 CDNs, one of 3 CNAMEs back that point to the CDNs instead, so completely transparent to the user. So it lets you do something really powerful with something quite simple. It's basically, so the rules are normally updated by the web UI, which is great, but it can be slow and error prone if you have, like us, 3 image setups, 3 domains, 3 changes have to be made. And if you're, for example, turning a CDN off in an emergency situation, you don't want to have to be making all those changes manually. Luckily, they do have an API available to do this programmatically, so we wrote a little tool called CDN Control.
So CDN Control, obviously one of our sort of requirements in the evaluation criteria was how flexible is the configuration. Like we wouldn't want to have to go, as Laurie was mentioning, go and make manual changes to 3 separate domains across 3 separate sets of CDN configurations there. So the first stab we had at it was just writing this little command line tool. So some examples of its usage. We have this simple command here which just says we're looking at the www domain, and -s is just give us the status, and that hits Dyn's API and returns what the current weightings are for those domains. So we have it shows us the 3 providers we have wired in there. The weightings at the moment are all even, and serve mode just says whether that CDN should be always served or whether it's not served. Another example of the usage here is for the site.etsy static domain. In this example, one of the providers is turned off and we'd like to turn them back on. So when we run this command, the initial display here just shows us, okay, this is the current state of the world. Serve mode is no, which means that CDN provider is not getting any traffic. We click yes, and boom, now they've changed and they're back serving in the loop again. And then the final example is, say we wanted to actually dial down the traffic for that provider. We just pass in the weight parameter there. We're going to drop them down to 1. Again, it shows us that the current state of the world, and then when we hit yes, it's dropped the weight back down to 1. So that second set of statuses are actually getting pulled from Dyn themselves. So this is what Dyn currently has configured, as opposed to what we sort of optimistically might want to have set.
It's a nice little thing to have also. We built a UI on top of this. So this is showing the same thing, but with a nice slider, easy to use, and you get the advantage of having the graph live updating below the information here as well. CDN Control, both parts of this are open source. The URLs will be at the end of the presentation. So there are some downsides to using DNS for balancing. For example, to be able to make those changes quickly, you're going to want to basically remove all the caching of it. You need to set the TTLs for the record as very low. And the problem with that is more queries per second is more money normally. So you have to get the right balance of being able to make fast changes, but also not running out of money, which is not ideal. It also has a performance implication as well. Because the cache is only 60 seconds, now you're going to have to make way more DNS lookups. Every couple of page loads maybe, the TCL is going to have expired, you have to go back and then look up those records again. And also it isn't 100% instant or deterministic, so we have a 60-second TTL, and in our experience it does work pretty quickly. So here, for example, you see 50% of the traffic is actually gone within a minute, but then the long tail is very long. It lasts for a little while, which is really annoying. Like we can't control the DNS infrastructure around the world. It's up to ISPs and such to do that. So
there's been some really interesting characteristics with that as well. Is we'll see like huge chunks drop off in 2-hour blocks and 4-hour blocks. So if you're from an ISP, please be more friendly. All right, so now we're kind of all ready to go. How do we actually deal with monitoring in production? It's 3 a.m., the pager goes off, you're like, what the is going on? So debugging becomes a much more interesting problem when you have 3 CDNs. You're not controlling that infrastructure, so we need to kind of like hack and cheat as much as we can to get the information that will help us sort of troubleshoot problems as quickly as we can. So one of the features that we've implemented is a thing that we call just affectionately the whoopsie page. So anytime the app servers return a 500 error, or the CDNs, for instance, can't reach origin, we have the CDN server page that looks a little bit like this. Typically, if you're not doing something like this, you may just get like a horrible looking Akamai fail page, or you might get a Guru meditation error if you've got someone who's using Varnish. And with this, it allows us to just sort of add some Etsy branding. We translate all of our error messages into all of the sort of predominant languages that the site uses. And we also include links to the status page. So if we actually are having a legitimate outage, we are really sort of communicative and let the community know that we're having problems. And having this whoopsie page lets us do a few other sneaky little things.
One of the things we do to help the whoopsie page help us in return for masking it is this thing called failure beacons. So right at the bottom of the page, there's a 1x1 tracking pixel embedded right at the bottom. So it's an invisible image. When the user hits the whoopsie page, they're going to load that image, and it's going to create an access log line back in our logs. And this is served by a completely different infrastructure, so it will always come back to us, even if the CDNs are having issues. We then use an open source tool called Logster that uses basically regexes to scrape out log lines, and then we use that to post it into Graphite, which we use for all our graphing. So then we have a graph that looks like this of per CDN, how many whoopsie pages are being served per minute. And then the really cool thing we do on top of that also is we have a plugin to alert on Graphite graphs in Agios. So now we have 3 alerts, 1 for each CDN, and if we have more than 100 failures in a minute, the on-call person gets paged, we can wake up, turn off the CDN, and try and figure out what's going on with that.
So that's pretty awesome, but wait, there's more. Since you're getting all of these requests from the clients, you actually have the client IP addresses in the logs as well, which allows you to do some geolocation. So when you take in these IP addresses and start geolocating where they're coming from, this is a real example of something that happened where we were having a particular problem with a CDN in Belgium. So we were seeing a huge spike in the whoopsie graphs saying, hey, this provider's having problems. We were then able to sort of throw it in here and go, well, it's not global, which the general rule of thumb is if it's a global error, it's probably us. If it's a regional error, it's probably them. But it was able to allow us to sort of go, well, look, there is a problem in a very specific geography, but everything looks fine everywhere else. The benefits of this is it allowed us to identify it really rapidly, but we're also able to tell both our support people, so when they're getting requests coming in from people in Belgium saying, hey, the site's stuffed, and we can also tell the CDNs, hey, look, we're seeing a whole lot of problems coming from this particular geography, and on more than one occasion, we've found it before they have.
Two-way debugging is obviously really important. Like if you can share information back to the CDN, don't let them do all the work. You share responsibility for that, so you can get to problems much quicker if you do that kind of thing. One of the CDNs we use also actually adds some extra information, which is super helpful in that diagnosis process. Just some extra URL parameters for the provider error, and also the identity of the server that was caused causes the whoopsie page. And with some quick, terrible bash magic, you can then obviously pull that out and say, okay, obviously there's one particular region or maybe one particular server that's having a lot of issues. Again, you can jump in ISC and say, we're seeing this, and it's much quicker. It's two-way diagnosis versus just relying on something else.
And this kind of dovetails back into that evaluation criteria of like culture. It's like, how much of a relationship can you establish with your providers for them to actually go a little bit more out of their way and sort of go, well, look, we can provide you with all this information really cheaply and easily. And not only does it help us, but it also helps you as well, which is like really, really cool. So that's something really to consider when you're doing your evaluations. So now that we have multiple CDN providers coming back to Origin, the traffic is essentially opaque to us. We're just seeing requests coming. We know that they're being served by CDNs, but how do we actually identify those? So we implemented this other way of tracking requests that come back to Origin. So inside each of the CDN configurations, we have them add a custom request header that comes back to Origin. It's just X CDN provider, and we tag that with the name of the CDN provider that comes through. So in our Apache logs, we're pulling out the contents of that header, inserting them into the access log, and again using Logster to scrape those entities out and graph them with Graphite. It allows us to generate sort of graphs like this. The color scheme's not particularly good on a projector, but each one of those bands is a separate CDN provider. The top band is requests that have come through that don't have a tag, so it's from internal monitoring or other things that we're doing that comes directly back to Origin. And it's a really cheap and easy way. Like, don't be scared of abusing request headers and Apache logging for really cheap and deep metrics.
So as you mentioned, we're using the vendor APIs to bring the data back into house. So a couple of cool things we do with this. For example, our dashboards framework, we have a dashboard that we lovingly call the CDN Fight. And so because we have these metrics in-house, in a similar fashion, we can compare them directly side by side and say, okay, what's the traffic looking like in direct comparison to one another? And you can see in this example, one CDN being turned off and the other two taking up the traffic, which is super helpful. So there's tons of comparison graphs on here. There's a couple of other advantages as well of having, you own your own availability here, so having them in-house is fantastic because you're controlling the data retention period yourself. Maybe the CDN has awesome metrics but throws them away after a week because they don't feel it necessary to have it any longer. Well, we've now got a copy of that, so we can keep that for 5 years and then view trends and such, as well as having that consistent and unified view. And the other cool thing is it does mean that because they're in Graphite with all our metrics, it's integrated into our open source anomaly detection systems. So, we can start to correlate external problems and internal problems together to again, help us try and figure out problems quicker and easier.
Yeah, so now that we've created all of this additional complexity on how a page gets served to a user, and we have 100 plus engineers, and they're deploying the production code to the website 60 plus times a day, it's really important now for us to be able to take these metrics, make them available to everybody in the organization, so that they have awareness about what's going on, what the state of the world is out the front, and how what's happening on the external side is affected or is being affected by the internal side. So we have, this is affectionately known as the deploy dashboard. If you're deploying, you have this up on your screen. On that, we've added a few extra features now that we have the multiple CDNs, such as up the top. At a glance, you can see what the current ratios are across all of those three domains I talked about earlier, across the three different providers. Down the bottom there, you've got the request balance, so you can see at a glance like how's the traffic currently being distributed or coming back to Origin from each of the CDNs. And then lastly, we have the whoopsies that we talked about, the failure beacons. We've broken them out by provider. And then the secret sauce there is our vertical line technology. You can have it too, it's really cheap. And for each deploy or for anything that makes a sort of a significant change to what's happening on the infrastructure, so maybe your chef change goes out and it's modified a whole bunch of things on a bunch of servers, or you've made in these cases a code push. You can really visually see this is where something we did changed, and then the graphs changed after that. In particular, with this from a CDN perspective, once you've done a deploy, you would not want to be seeing all of those whoopsies traveling in lockstep, because it means you've probably broken something.
So front-end monitoring, on the front-end monitoring side, performance is really important to us. We actually have a monthly blog post we post on the Coders Craft blog, sharing the current goals and how we're doing performance-wise. So when it comes to implementing multiple CDNs, not only do we want to make sure we're not making the site slower, because that would make everyone very sad, but also per CDN, like, is one of them slower than the others? You may have seen before that we want them to be within a certain tolerance. So how do we go about measuring that? And what we do is use real user monitoring on our key pages to keep track of that.
So here's an example. So we use a product from Sosta called Impulse. It used to be called Log Normal, and it's based on the original Boomerang technology that Phil Tellis wrote back at Yahoo. And it puts beacons on the pages and essentially reports back using the timing APIs in the browsers when the key sort of events have happened on a page, so full page render. So we are able to tag those events, again, as they're being sent to Impulse. We're able to tag which CDN was enabled for that request. And then we're able to generate dashboards where we can actually break the page performance out by CDN. So in this example, the large numbers are median full page render. We've also got 95th and 98th percentile there. We get a nice scatter plot showing what the load time was for all the measurements, and then we can also see the distribution in the histogram of how each of them are performing. And this isn't a made up graph. This is a real one. And and all of the providers were happily meeting our requirements for being sort of pretty close to each other in terms of performance, which is pretty awesome.
So what about some downsides? Narrow in production. So debugging stuff, again, this is a big topic. Mean time to detect and mean time to resolve can be extremely low with this system. We have those failure beacons and such, and when you see them come in, you turn the CDN off, the whole process is taking about 5 minutes, job done. But that's not, unfortunately, always the case. When implementing this, we had a few fun issues with 5 or 6 users that are emailing in saying that on SSL pages only, suddenly they can't access the site or images are missing, and we managed to nail this down to just 1 or 2 CDNs. And so after a lot of backwards and forwards, after a number of days, almost a week, I believe, I get this lovely message back from a user, and the reason becomes clear of the issues. Windows updates. Who loves that? People are so afraid of Windows updates. They totally mess up their desktop. And Microsoft, damn them, they insist on plugging vulnerabilities that don't apply to them.
They're my kind of vulnerabilities.
How careless of them. So eventually I managed to get a screenshot of the actual problem, and you can see this yellow exclamation mark on the GeoTrust cert is basically, it's a root cert. Every computer should trust these. But because the person hadn't installed Windows updates for so long, they just weren't trusted. Our certificate was fine, but they were not able to load any SSL pages. So after manually installing the knowledge base package just for the root certificates, still can get them to enable Windows updates. We had a happy ending, and I actually got an invitation to dinner at this person's house for fixing this particular problem, which unfortunately I couldn't take on. But it was there's a lot of confusing issues that can happen, especially when you have 3 things going on at once.
So when it comes time to debugging, getting to the bottom of what's broken is really hard. We have an amazing member base of buyers and sellers, and they sell really awesome things, and they love to buy really awesome things, but they're pretty non-technical. We take it for granted that we can just view the source or pull the headers apart or run Wireshark and see what the hell's going on, but we don't get anywhere near that kind of level of anything. It can get really confusing and time-consuming to try and nail down, like, where is this problem occurring. Our support team, again, have this kind of weird ESP thing where they can filter the noise out of the signal, or the signal from the noise, sorry, and give us their interpretation, which generally is much better than the original text, as we saw with the Windows updates thing. So they're able to ask really good questions. And in setting up all of our back-end monitoring and our front-end stuff and trying to get as much visibility into what's happening with the different providers, it really helps us sort of get to the bottom of what these problems are. It's by no means a solved thing. We get lots of really awesome curly questions, but we also add a whole lot of other details to all of our logs. For instance, every request gets a unique identifier, which we can trace through the entire infrastructure, even back to which CDN delivered that request. So we're doing our best to fix it from a technical point of view. Support are doing their best to fix it from like a human point of view, and the CDN providers are, now that they're sort of working more closely with us, sort of really help us get stuck into that.
You haven't lived until you've seen a screenshot taken with a physical camera and then scanned and sent it into you. It's quite something. So some conclusion and takeaways. We're coming to the end of this now. It's been 12 months. There are some downsides that we mentioned, but actually it's been pretty awesome. We're pretty happy with what's going on. And Marcus mentioned Cyber Monday is just gone. Everything's nice and stable, and we're very happy with how things have gone. Doesn't mean we're stopping here. For example, you may want to investigate doing CDNs per region, starting to filter that out a bit more. So anything else we do, obviously, we're going to share along the way, just like this. And along with that, the open source links that I mentioned, a bunch of this stuff is available. The slides actually are already online from Velocity as well, so we'll make sure we tweet those so you've got them. And that's it from us.
Cool.
Any other questions?
Whoa. Sorry, over. Thanks, guys. That's really interesting stuff. So when you make a policy change to the distribution of requests to a CDN or to turn one off, about how long does it take to really propagate out and start populating the cache and sort of getting back to steady state, including DNS? I mean, the whole thing. I know that the DNS piece is a chunk of it.
So it was that graph that we showed before was actually live traffic using the logs to requests that came back to us. So 50% had gone within a minute. So it's actually really fast for the first, but of course there's always that long tail. And I guess it's the final 1% could be weeks, sure, because there's always people out there. There's a couple of really common bots and stuff, not even real users, that just actually completely ignore TTLs entirely and then wait until like 2 weeks has passed before they actually go look up DNS again and stuff like that. So we don't have an exact number for exactly how long all the users take, but it is within it's probably a couple of hours.
And I think in the question there, you're also asking about when we make configuration changes to the CDNs themselves, so what they're actually doing. So there's two aspects to that. One is we try and move the logic, as much of the logic to origin as we can. In some areas that's like totally not feasible, so we do need to make changes. So when we are doing those configuration changes on the edge, we'll pull a provider out, we'll make the change, we'll do some testing, and then we might do the other two. Any one of those CDNs can take 100% of the traffic at any time, so we can just axe two of them and have one doing 100%.
Yeah, it's n+1 for a reason. You could stop at 2, right? But then when you take that one out, you've only got one left. So
we actually got saved during Hurricane Sandy, actually, because our origin data center's in New York, and one of the CDN providers had a really major issue, and the alert went off, and we just turned them off, and everything was cool, smooth sailing. Yes, the front.
So you guys have 3 CDNs right now. How many did you actually pursue or look into? And then also, I guess just because I think a lot of us have never considered multiple CDNs, what is the state of CDNs overall? Is there a wide variety in the requirements that they impose on you, and costs and speed and all that kind of thing?
All of the above. and that's where kind of having the flexibility really comes into play. We tested in total around about 5 providers and ended on the 3 that we did. And that was...
Are you willing to share who you did go with?
No. You can talk to us lately. It's not very hard to work it out. So, and you probably work for them, so you're going to come and talk to me later. So there's a whole lot of different aspects, and when you do start running multiple CDNs, some other levers that you can throw is you can start to work with them on, well, these are our requirements and we need this feature. We really want to work with you, but how do we make this work beneficially for all of us?
And because you can nail down this testing framework, how you can test it so quickly and easily, then ask for a demo. Salespeople like to give you demos because they want you to buy their product, so you can give it a go without any kind of obligation, and if it works out, it does, and if not, it doesn't. We ditched one at the meantime to curl phase, for example. So it's 10 minutes, done, move on.
And And one thing that was like, when we sort of went through that evaluation criteria, performance was up there, like it was really important. Like we don't want a new provider to be any slower than what we already have. But there were so many other factors that we were considering, like how easy are you to work with, how much flexibility we have and how we can do it our way, how quickly can we make configuration changes to have like the agility that we have internally. Like we would hate for a feature launch or like an API change to be held up for 2 weeks because professional services need to make a change. So we need them to be able to move as fast as we can, and we want like their skin in the game as well. Like we want them to be successful, and we want them to sort of be really excited when we're having success as well.
Thanks. Was a web application firewall at all part of your criteria? And if not, is that at all used in your stack elsewhere?
We're not using anything at the moment, and it wasn't in the criteria.
I mean, that's something that I guess you'd hope would be at origin, right? If you're going to have to configure that in 3 CDNs, and then, oh, whoops, I forgot to make a rule change on one of them, this, that, and the other, so if you can, obviously we have firewalls full stop, but they at origin instead of at CDN. Just regular firewall.
And we also have some other things in place as well, external to the CDNs, that we can kind of use if we need to use.
You explained that you're having to manually tweak the code when you are seeing a lot of failures to shut down one provider to shift to another. Have you explored any tools or considered building your own tools to sort of automatically react to those things and be able to shut down a CDN provider when you know that there's something else that can step in and take its place?
CDN Control obviously is that one-line command. So that's kind of like, we always have someone on call anyway. So we took the decision right now that if something's going to go wrong, that person's probably going to get paged anyway for something. So they are able to make like a conscious decision on what's going on. We did investigate. Also it's very complicated. There's a lot of heuristics around disabling something automatically when there's a failure. So that's why we kind of erred on the side of caution and be like, let's actually figure out what's going on and then turn them off as a result of that or something.
Traffic Manager has the ability to configure health checks, and you can say, if you fail a certain number of health checks, pull that provider out and don't put them in. We have to manually put them back in so you can avoid that sort of chatter state. Which we fiddled around with a little bit as well. So we picked one CDN. It's like you're always going to be on, but the other two can flop in or out. But just getting the heuristics right about what is the right health check. The whoopsies are generally a much better leading indicator for us than what the DNS was able to do from a health check perspective. So human intervention, even if you're bleary-eyed, you can just like log onto the console and just hit the button and it's out.
And you can leave it, of course.
And you can just leave it out.
Yeah, 3 a.m. and you can't figure out what's going on. You can turn it off. You've got 2 others. As long as the other two are functioning correctly, you can just go back to bed and worry about it tomorrow, kind of thing.
All right. Well, thanks. So now that you have 3 or n CDNs, and you have the ability with real user monitoring to start to see performance distributed across the globe, are you starting to observe different, in your histograms of CDN performance or the equivalent, different kinds of strengths and weaknesses with your CDN partners depending on where your origin customers are?
Yes, and it's something we're exploring in a little bit more depth. Because now that we have this level of control, and one of the cool things with Traffic Manager is we can actually break things down on a geographical basis. So we could have weightings. At the moment, we just use a global weighting. Right. But we could have the weighting shifted that we get better performance in a particular geography from a particular provider, or we get a better price at certain times of the day. We can dynamically alter those rules. And
you would implement that by hooking into Dine's DNS services?
Most likely, yeah. That's how we're doing it at the moment. It's something that we're exploring. This is sort of still pretty early days, and I mean we're a global company, and our goal is for performance globally to be pretty much on par. So if you're in the US, the site's awesome. If you're in Malaysia, the site's awesome. We want everyone to sort of have the same experience.
It's kind of a tangent, but how, in all your testing of the CDNs, have you noted, or can you quantify how sensitive your users are to delays in delivery?
Good question.
We are. The person to talk to is down there.
Yeah, we do have. Yeah.
Seth, who did the introductions,
heads
up the performance side of things. And we've actually done some experiments where we've, similarly, there's a lot of published, some published reports from like when Google and Microsoft and everyone slowed the sites down and looked at their conversions. We've done some similar experiments internally, and the results have been pretty consistent with what everyone else has seen. So being conscious of the performance impact, and that's why we wanted to really make sure that like we're getting consistent performance across everyone, because if it starts to deviate, we know that we're going to actually see like conversion loss and things like that. So it is something we're paying a lot of attention to.
It's pretty interesting how different countries react to different slowness as well. The bounce rates, obviously in the US, people, and the UK, people have usually good, fast speed, are very conscious of things slowing down, whereas like Australia.
Australians are much more patient.
They're always used to everything being slow on the internet, so they're more willing to hang around.
So on the positive side, we actually go really fast in Australia compared to most of the other Australian sites, so they're kind of getting a bit of a shock. Makes the other guys feel slower.
Anyone else?
Did you guys have any challenges getting this concept of multi-CDNs sold within the company? Did you devote the resources to be able to do it?
That depends how you look at that cost point on the second slide.
Exactly. Well, we love all of our CDNs equally, so it's they're all providing consistent performance. We like them all evenly, and if they fall over, we know that we can just turn them off and have a conversation in a postmortem about what went wrong, and they'll come and have remediation items, and we'll hug it out, and it'll all be great.
And they have been awesome. Like as we mentioned, one have come to a postmortem. Another one of them has started doing public postmortems since, because we just said to them, you can do this cool thing where you actually tell people what happened, as opposed to saying, oh, that guy got fired because he pressed the wrong button. Right? So.
But also in terms of like company buy-in and with some of that sort of testing procedure, it was ridiculously cheap and ridiculously easy for us to test with production traffic for basically no money. So it's like, we have this concept, does it look like it will actually be beneficial? Let's spin it up and try it out. And when it, through all that testing phase, we went, well, look, this thing looks like it'll work. We can steer the traffic, performance looks good. Now we can start having the conversations about how we put it into production. It's a no-brainer sell. It's not like we sort of had to say, oh, we're going to have to take the site down for 6 months and re-engineer how we're going to deliver the front end. So we started testing 3 providers. One fell quite early, and we continued on with 2 additional. And then we ramped the 3rd one up. Like, we'd already proved out like how we can do it, and we ramped the 2nd one up really fast. So if we were to do it now, roll in another provider, it's like a very low stress, pretty easy thing to do. The longest part was the testing, because we do need to let the caches warm up over a couple of weeks to actually verify that we're getting the performance and the offload that we're getting. And with our sort of traffic profile and the sort of general long-tailedness of like, there's a lot of people that look at a lot of really old listings, that how those providers respond to those characteristics. For instance, we've had to sort of really work with the CDN providers to work on their internal infrastructure of how they can best route like midgress points for us to get the best performance traffic-wise, to get the offload that we expect.
And now they start battling each other to try and get the best hit rate.
It's pretty cool.
Pretty fun.
It's like, they're getting 89%. We're only getting 87. That's how it sounds. Done.
All right.
Thanks.
Thank you all for coming. Feel free to stick around and talk to these guys or yourselves, each other. To each other. There's snacks, there's beers. Like I said before, sign up for the email list. Follow us on Twitter, CodesCraft. All right. Thanks, you guys.